Good morning, dear students. We shall study the new chapter, waves. In this chapter, what are the topics we are going to study? Firstly, we will understand what do you mean by a wave, what it does. It carries energy with it and momentum, and it propagates from one place to another, transferring energy and momentum. Then we will study the types of waves, basically three types. Then we'll study the how to represent a wave, what is the speed of waves, sound speed given by Newton. There was some shortcomings in it, was corrected by Laplace. So we'll study Laplace formula for speed of sound. Then we'll study on what factors the speed of sound depends. Then how what happens when two waves adds each other. Then we'll study the effects of superposition. There are three effects we will study. First one is the interference, second one is the stationary or standing waves, and third one is the peaks. We'll see one numerical also based on the waves. So firstly, what is wave? I have already told you is a disturbance that travels through a medium, and it is transporting, it is carrying energy and momentum from one place to another. Since the wave is going from one place to another, wave is carrying with it the energy and momentum. But the important thing here is there is no physical transfer of matter. The matter remains at its place. Let us have an example of it. Suppose that it is a pond, and at the bank of the pond, you are sitting, and what you're doing, you are just having a pebble, a stone in your hand, and you just throw the stone in the pond. The moment you throw the pond stone in the pond, what you will see? You will see the water waves. You will see waves on the water surface like that. So what I'm trying to teach you is the the water particle which was originally here will oscillate up and down, but the water particle will not go ahead. The water particle will remain here. It will move up and down. So what happens? The matter is not transferring, but what is going on? The energy in the form of wave is going from one place to another place. Now let us move ahead. What are the types of waves? As already mentioned here, there are basically three types. One is the mechanical, second one is the non-mechanical, because electromagnetic waves are non-mechanical, and third one is the matter waves. Mechanical, as the name suggests, the one which requires a medium to propagate. And non-mechanical waves, you can write electromagnetic as non-mechanical, which do not require a medium. For example, the light is coming from the sun, got to the earth, and there is no any medium, so they can travel through vacuum also. All right. Yes. What they are made up of? They are made up of oscillating electric and magnetic fields, but you will study this chapter in basically electromagnetic waves in 12th class, and so no need to discuss about electromagnetic waves. And matter waves also you will study later, that the electrons and protons inside the atom are not stationary, they are also moving. So what are the waves associated with them? Actually, de Broglie gave some law, and you will study in the 12th class these two types of waves, right? Now we shall constrict ourselves to this topic, mechanical waves. We are going to study these mechanical waves. Dear students, what a wave, mechanical wave require? It requires a medium, and that medium should have basically two properties. The first property is it should have inertia, and second one is it should have elasticity. So, sir, I'm not able to understand what are you saying, elasticity and inertia. Dear student, let us have again understanding of this point. If you are having a stone and you're sitting at the bank of the river and you try to throw a stone, a pebble in the river pond, what happens? You will find that the water waves on the surface, water surface is there. See what is going on here. The moment you throw a stone, the water moves up and down, right? When the stone just goes inside the water, it creates some disturbance in the water. Now this water gets displaced from its position. The water is there because it has created some space, so the water is something like displaced from its position. The water goes down. Now, due to elasticity, as the water particles move down, due to elasticity they tries to move up, but due to inertia the water do not remain at the equilibrium. It moves some more distance than the equilibrium position than the mean position, this water level position, because due to inertia it moves somehow more than the required distance. Then again elasticity comes into play, and due to elasticity this water molecule which has moved up now tends to come down. Due to inertia it does not remains at this mean position but it goes down. Okay, I hope it is clear to you. So due to elasticity and inertia the particles moves up and down. This is what it is creating a wave. The same I have mentioned here. The medium should have these two properties, then only the mechanical waves are possible. Now let us move ahead. What are the again mechanical waves types? There are two kinds of mechanical wave. You have already studied these points in ninth class. The mechanical waves transverse and longitudinal. Transverse wave when medium particle oscillates perpendicular to the direction of propagation. For example, let me draw an example here. Let us suppose this is a wall, and here you have a boy standing here, and this boy is having a rope in his hand, and what he is doing, he is just creating a wave in the rope. This is a rope, and the rope is tied to a wall. The rope is tied to a wall. So what is happening here? You will find that the rope particles are moving up and down. This is rope particle, this is rope particle, this is rope particle. It is moving down, going up, moving down, going up. But the rope do not move ahead. Only the wave is going ahead. Only the wave or energy is going ahead. But the particles are at their remain position. Particles are at their particles are just moving up and down, not moving ahead, right? They are just oscillating, not moving, right? So try to remember, wave is moving but particles are oscillating. Dear students, the direction of wave is forward, but the direction of oscillation of particles is perpendicular to the wave propagation. It is oscillation direction. It is oscillation direction. So particles are moving up down, but the wave is moving in forward direction. Can I not say this, that the medium particles are vibrating in perpendicular direction to the direction of propagation of wave? So this is what transverse wave. Now let us talk about the longitudinal wave. I hope this topic is clear to you. Longitudinal wave is a wave in which the particles are oscillating parallel to the direction of propagation of wave. And for example, the sound wave, because in ninth class you have already studied that when sound propagates from one place to another place, the air particles are oscillating back and forth, not up and down, back and forth. The sound is moving in this direction. The direction of sound is from one place to another place, and also the direction of oscillation of medium particles, the direction of oscillation of air particles are also along the direction of propagation of sound. So it is a longitudinal wave.